right, we are going to do another derivative of an inverse function. This time for f of x, which is x cubed minus 4 over x. And we're going to do that at a value at a equals 6. And we're only going to be looking at the domain of this function where x is greater than 0. Alright, so first of all, we can't find the derivative of the inverse function if it doesn't have an inverse function. So we could either A, graph this, know what the graph looks like, and make sure it has an inverse function by making sure that it's 1-to-1, meaning it passes the vertical and horizontal line test. Or we could use what we know about derivatives, which we're going to need to know the derivative anyway. So let's go ahead and find the derivative. It's like the power rule, and let's rewrite this so we can use the power rule again. And simplify it a bit. Okay, so there's the derivative. Now, since we're only using these x values, well, no matter what x values we were using, this would always be positive, and I guess this would always be positive too. So since the derivative will always be a positive plus a positive, the derivative will always be positive. That's important because that tells me the derivative is, or the function will always be increasing for these x values. So I have no idea what this looks like, at least off the top of my head, but if the graph's always increasing, it's certainly going to pass the vertical and horizontal line test. So it does have an inverse function. So the next thing, I think what is very helpful here is to think about what the format of the derivative of the inverse function is supposed to be, because that gives me a good reminder about what I need to go and find. So the derivative of the inverse function will be 1 over the derivative of f with the inverse of f plugged into that. And for our question, we're interested when a is 6. Let's get this in a different color. So we're going to be evaluating it for that. Okay, so I need to first evaluate the inverse of f at the value of 6. Alright, well, I don't have the inverse function, and switching x and y would put multiple y's over here, and that might be kind of hard to solve for, so I don't want to go that route. So instead, I'm going to think about the function, a point on the function, and a point on the inverse, and the big connection between these two. Okay, so I'm ultimately interested in when the inverse has an x value of 6, what is the y value? Because this is what I'm going to get to plug in right there. Okay, well, a point on a function and how it compares to a point on the inverse is inverse functions, you're just swapping x and y. So 6 on the inverse function is the same thing as 6 or 6x on the inverse function. It's the same as 6y on the regular function. So now I can ask myself, well, where does the function have a y value of 6? So let's go ahead and set that function equal to 6. Now this one would be pretty hard to solve algebraically since this is a cube. So I guess it kind of depends on if you had a calculator. If you had a calculator, you could graph this as y1, you could graph this as y2, and you could see the x value where they intersect, and that would be a pretty quick way to get a solution there. You could also subtract the 6 over and use the solver part of your calculator, but again, that depends on if you had a calculator. Short of that, I would probably assume that it's going to come out to some nice whole number here, so I would probably just do a little bit of guess and check at first, at least, just because that would be quick if I could guess it. So if I tried 1, this would be 1 minus 4, and that definitely doesn't equal 6. And if I tried 2, that would be 8 minus 2, and that would be 6. So you may not get that lucky, so you may want to use your calculator there. But so when x is 2, y is 6, which means on the inverse function, when x is 6, y is 2. And that's important because this now represents that. So I can come down here and say this is 2. And now I want to plug 2 into the derivative. And I already had found the derivative because I used it to make sure that this was going to be a one-to-one function. So plugging in 2 here, this would be 12 plus 4 divided by 4, which should be 1, which gives us, in the end, 1/13.